This example is to illustrate writing a vector when its magnitude and its direction are given. So we're going to write this vector as an AI plus BJ in that form. And what they're going to give us is they're going to give us the magnitude and they're going to give us the direction. So every single time, if they do this, let's just read this example here and I'll talk about the procedure first. Got ahead of myself a little bit there. So it says a ball is thrown at an initial speed of 90 miles per hour. So there's our magnitude in a direction that makes an angle of 30 degrees with the positive x-axis. So we have our magnitude and we have our direction. It makes an angle of 30 degrees with the positive x-axis. So what I would do in this case every single time is I would just draw a picture. So if we draw a picture, x and y axis, we know we make an angle of 30 degrees. So we have an angle of 30 degrees. So just draw your angle in standard position. Watch the quadrant that you end up in, because it may be something that ends up in the second quadrant or something if you have an angle that's more than 90 degrees. But just wherever your angle ends up, whichever quadrant you're in. And then label the hypotenuse, which is basically what they've given you. That's what the magnitude represents. It's the length of the hypotenuse. So we have our magnitude right there of 90 miles an hour. And so I can write that as 90. So I have my magnitude and I have my direction. So I'm going to write this velocity vector, I'm going to call it V. I'm going to write this in terms of I and J. And then it says, what's the initial speed in the horizontal direction? That would be my value for X, for A in this case. And what's the initial speed in the vertical direction? That would be my value for in front of J. When I write this vector as an AI plus BJ component. So that's the first thing I'm going to do. I'm going to write this vector in terms of I's and J's. So I'm going to make me a triangle. I'm going to make me a right triangle. And I have X and Y values there respectively. So I can use right triangle trig to find these values. So I know that the sine of 30 degrees is equal to y over r, in this case y over 90. And so 90 times the sine of 30 degrees, that will give me my value for y. And 90 times the sine of 30, which is a half, is going to give me y, and so y is going to be 45. I can do the same thing for my value for x. I'll do it in a different color here. So cosine of 30 degrees will be x over 90. And so 90 times the cosine of 30, that would give me x. And so 90 times cosine of 30, which is going to be the square root of 3 over 2, would give me my value for x. And so 45 times the square root of 3 would be x. So in terms of my I and J components, my velocity vector, which I'll call it V, my vector V here. Again, your horizontal is the value for x. So this is 45 square root of 3 times I plus, and in the vertical direction, my value for y is 45j. So I was able to write my vector in terms of its horizontal and vertical components, in terms of its I and J components, just using my right triangle trig by drawing the picture. And then it asked me for what the initial speed was in the horizontal direction, what the initial speed was in the vertical direction. And I have those values as well. In the horizontal direction, write it in red here. In the horizontal direction, that would be my value for x. It was 45 times the square root of 3 miles per hour. And my initial speed in the vertical direction would be my vertical component, so that would be 45 miles per hour. So anytime they give you the magnitude and the direction, you can always write that vector in terms of its horizontal and vertical components. So you can write it in terms of a times I plus a b times j. And we do that with just drawing our picture and using our right triangle trig. And that's the way I would proceed every single time.